My name is George Amigol and I'm a student of the Advanced Game Programming course at Fanshawe College, Ontario, Canada. This video is to present the results for the midterm of the Graphics1 from the fall term, the first semester of the course. And this is the very first midterm for graphics, and as you can see here in this scene is the answer for the first question. I will show you a little bit of the assignment here, so you can have an overall idea of what it's about. Okay, and we have to set up some scenes and make some movements on some models from this TV series Battlestar Galactica from the 70s. So a little bit of background history here that the professor gave us, and some videos that we can see how it was filmed and how it should look like. And he also was kind of giving us the models to make to assemble a scene, so it would be easier to do, and actually it would be harder if we don't have it, so they always give us some models to start. Okay, some descriptions here about the assignment, how it works. And this is the first question. So we have to make a scene to recreate this scene, and with at least 2 dozen raiders. I guess the raiders are those guys, I guess. Let's see. Yeah, like the aliens. The Vipers are those. This is the Galactica. So coming back here, recreate a scene with at least 2 dozen riders coming for an attack on the Galactica with at least 2 dozen Vipers. The good guys coming out to meet them. And here actually at least a dozen, not 2 dozen, 2 dozen for the riders. Okay, use your discretion when placing the camera, but you should be able to see all the models. So here you can see all the models, right? And the riders should be flying a perfect formation, as you can see here. They are all lined up against the Vipers and the Galactica. The riders should be flying in a perfect formation, okay, but the Vipers should be in a more disorganized arrangement, like this. So he gave us some tip to build our scene, and here you can see the result for the scene. Okay, those are the riders coming in a straight line to attack the Galactica, and the raiders are like randomly organized in front of the Galactica, as you can see. Get closer. Okay, and for the code, I'm building this game engine throughout the course using code from Finis from Fini and implementing some other codes like camera, etc. And for this first question, we have a scene loader that it's very basic, and we'll build our entire environment with game objects. And as you can see here, I loaded Galactica. Actually, let me show you here in the model utilities. We have a loader for the mesh. Here's the Galactica. And we have the loader for all the meshes. The Galactica, the Viper, the Raider. And the meshes are used by game objects to build a scene. For instance, this game object has the mesh, the Galactica. And here we can place a game object in our scene. We didn't actually had to put a position for the Galactica because he's already spawned on the origin of the scene. But here I can, I changed the color, the RGB color for the Galactica, those three first values. Okay, and here those are all game object stuff that we can set. Let me show you a little bit of the game object. So it has position, scale, velocity, acceleration to be used by the physics engine. And we can say whether it's updated by the physics or not, the type of object, and etc. Okay, so here I say that it's not updated by physics. I think none of this for this scene are updated by physics. They are static, just to make the scene work. And it's not wireframe 2. And then we push in the vector. There is a global vector of game objects. The same for the Vipers. The difference is that here I create 16 Vipers, a little bit more than 12 that he's asking. And I changed the position manually here, a little bit tedious, but it worked. So for each Viper I changed the position. I could have used some random function for that, but it would take me longer to accomplish. So I just went with the position manually, with some differences here in the position. Okay, this is for the Vipers. And for the Riders, I create 24, 2000, and then I reposition them with here the position what I used for the Z axis, that is horizontal. Let me show you here so you can understand better. The Z axis goes this way, the Y is up, and the X is to the right in this scene because we've seen it from the back, I think. Okay, and for the position of the riders, again, what I did was putting it in 400 negative in the Z-axis, so it went from that direction to here, and then for each Viper, I put the position along the x-axis. Okay, I started like minus 120, so I started from here and all the way to here. I increment by 10, I think, yeah, for each game object. Okay, so this is the first question, to make a simple scene static to present what he's asking in this question. Okay, very basic, a lot of manual stuff, not very well coded, but it will do. Okay, so for the second question, what he's asking is to place lights in the engines and landing bay of the Galactica, here and in the 4 engines, like in the picture below. 2 point lights per landing pod, so we would have 1 point light here on the end of this landing pod and 1 point light on the beginning for each side. That's what I understood from this. Beside the landing pods, 1 near the front and 1 near the back, so that you can see the triangular landing bay here. So for this question, what I did here in the main, I manually positioned all the lights. Okay, so I have this first light. First I have a light object that controls the light stuff in the scene. Okay, so for each light that I create, let me show my light object here. So I have this function and I create 9 lights and use this other function to load the shading uniform locations to the current program ID. Okay, and then I manually place all the lights that he's asking in the scene. So for each light, I position the light and I set all the parameters needed to accomplish the result that he's asking. So I have this sunlight that's not necessary for this question. It was already there, but here on the engines I have 4 engine lights, and here I mess around with the parameters for attenuation, so we can get like a very concentrated light in the engines, and I change the color for a bluish color and the position for the 4 lights, and the same for the landing pod lights, a little bit yellow, as you will see in a bit. Okay. It's taking more time because for this question I loaded the very high resolution model for the Galactica, because the professor gave us variations in the resolution, so you can work faster. But I think that for this question you can see the lights better reflected in this model of the Galactica. So here you can see the engine lights on the 4 engines. Can we get closer so you can be able to see the effect better? And in the landing base there are those yellowish lights. Okay. Get closer to get a better look. So we have in this side and at the end of the landing bay in the other side. I can show you. Being carefully to not get into the mesh. Okay. Turn around to see it better. Pretty simple to do because I had already lights working on the engine, so just change some parameters to be able to build the scene. Okay, so for the third question, so he asks us to place the camera over the bridge of the Galactica, and by pressing P, the camera looks at each fighter rider in turn. Okay, so in other words, each time you press P, we change it to the next ship to look at. When we see them all, return back to the first one. If you really feel you need to, you can move the camera, blah blah blah. So let's change for the third question. So what he wants is us to change the camera orientation we look at to the position of the objects, of the game objects, the other ships. Visual Studio is acting up here. Let me close and open again. Okay, so for this question, I changed the location of the camera to the bridge that he asked. Here, very basic. Set the camera orientation to. Those are all functions from the camera that I created for the game engine. I guess Mr. Finney the professor will implement a better camera, but for now I implemented this one. So here, as you can see, if I press key using the OpenGL key stuff here, the callback for the engine, I use also this function to keep track of each object I'm using. So every time I press key, I will change to a different game object until I hit the end, and it will set to 1 and start all over again. Okay, change the game objects. So what it does here, it set camera target. It was a function that I created that will basically do the look at work. I didn't, at this point, I didn't know the look at function from GLM. I guess it would be better to use that. So I came up with this look at kind of thing. So I set a camera up vector, look at, I bring the look at to the origin, and make the it like here. I have a vector, vec3, and what I do is subtract the target from the camera position, so I get the look at the origin. Okay, a little bit of math here. So after I get the look at the origin, I normalize it, and then the look at position will be ready to be added to the I have a new look at position here, and I add to the look at position here, adding with camera position. I don't know if it's clear, but it's basically math. What I do is bring the vector to the origin and reorient it to what I want to, like my target here, and add to the camera position again. So I pass the target, okay, and then here I have the math to do the work. And basically the target that I'm passing here is a vec3, and it is the position of the current game object. So in other words, what this function is doing is taking a position over the current game object and make the camera look at to that position. Okay. So let me run here the code so you can see what is going on for this question. Okay, so P, right? I just look at the first game object. Here I had positioned in change the order. This is the first game object. I think this is the second and third and the fourth and so forth. Okay, this is the second, the third, the fourth. You know, every time it changes the object, when I press P, it look at to the new object, and now as I don't have any more vipers here, it will change to the radars. Okay. And then start again, all over again. Except for the Galactica, of course. That's why if you remember, I put 1 here. The Galactica is the very first object, it's object 0. Okay, simple stuff too. Let's change for the fourth question, I guess. So here in the fourth question, press a button so the riders fly towards the Galactica. They don't have to reach the Galactica, blah 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 blah. This should take at least 5 to 10 seconds. Place and move the camera that so that this is clearly visible. Okay. So for this question, what I did when I press the riders, I set the velocity for all game objects. Pardon me, all game objects that are riders. So we have riders starting from 17, so that's why I manually put this magic number here, because here the last Viper is 16, and then start the riders at 17. This is just to mount the scene that he's asking. Okay, so it's not a good practice to use, of course, magic numbers. It's just to get the thing done. And here's the interesting thing. I have my game object with its own Professor Finney does the physics update, or at least he's doing now in the main file. And what I did was taking the physics update and bringing it to the game object itself. So all physics update happens here. I think for me it's better to understand that way. And actually I can change the behavior of how a game object responds to physics without changing the overall physics engine. So I just, for instance, I can make an object lighter than the others, and not changing the gravity itself, just making these changes. Okay, I will show you, because in this question I think I have done all the 7 questions already. So this is not the question that I already implemented, the updated behavior, but I will show you in a bit. Okay, so for these questions, what I do is set the velocity here. I think here we still have the physics here. Let me show you. Yeah, we still have the physics step here. And at the later question, I think it's the 5th or the 6th, I changed as I said, I changed the physics update to the game object. So you'll see this in a bit. But for this question, sorry for the confusion, but for this question, I just, when I press the R button here, I set the velocity in the z-axis for 10, and then in the physics update, you will hear the magic will will occur, will happen. Okay, so let me show you running. So you can see all the riders are here, but they are static. As soon as I press R, they start moving towards the Galactica, because now it has the velocity on the z-axis equals 10 here. If I press it again, what will happen is it's set to 10 again, so will not change anything, because it was already set to 10. Okay? And the problem with this physics here is that if you change the orientation of the game object and set the velocity for the z-axis, for instance, it will use the global z-axis and not the game object axis, z-axis, local z-axis. So that's why I'm change it a little bit and bring the physics and update to the game object. Okay, let's see if this happened in this question 5. Okay, so question, here I have the code for the question 5. Yeah, and the game object, sorry, camera game object here. Yep, now I have the definition for the physics update inside the game object. And as you can see here, I changed the orientation for that. It was a vector representing the rotations, and I changed for matrix, so it gets, I find it's way easier to do that this way with matrices, and to change your orientation, we just pass some values here and use the rotate function of the GLM. That is not relevant now. I just want to show you that for the speed, if you set a value here, for instance the z-axis, and multiply by your orientation, you will get a new vector for your velocity that you can use in your delta position, and this velocity will act on local axis. So if you change the orientation of your spaceship or something, and if you have your speed in the z-axis, that is like the head of the ship, it will maintain that direction. If you change the direction, it maintain the speed in that direction. Okay, but let's go back here for the 5th question. So he's asking us to press a button and to move the Viper behind the Galactica, then press and holding another button to have it landing on the landing bay. Okay, so Again for buttons, we have all those key callbacks here, and if I press T, I will change the position of one Viper. I think it's the first Viper that is like way in front of the very front of the Galactica, and place it near the landing bay, so it's like ready to land. And after that, if I press L, what I do is I took this position, okay, that is where I'm going to, and for each time I press L, it will take my game object position and subtract from that position. Okay, so every time I press L, it will get closer to that position. Okay, and then I made this little function here to test if I'm in a range. I will change the, because here what's going on is that I'm passing the landing speed to my position. Okay, so every time I press L, it will keep my position, but when I'm near, keep my speed, sorry, but when I'm near this range, it will slow down and will not move anymore. So let me show you. Okay, so T to place the Viper here, and if I press L, I will move all the way to the landing bay. Okay. As I did this, let me see. Actually, I think I'm not sure anymore what this speed is doing. Let me review just a little bit here. Okay, sorry about that. I was trying to remember what I did here, but it's basically doing uh, changing the position according to the target, that is this, okay, and subtracting on the final position. No, sorry, this is for the camera, because I'm also changing the camera together with the object. I place it like 0.5 in the y-axis, a little bit up, a little bit above the game object. So every time I move the object, I also move the camera position with it. Okay. What I set the camera position, taking the position of the game object and adding this little bit of offset to place it a little bit above the game object. Okay. So for the sixth question, what I asked it to do was to make a different loader. Let me change to the fifth question here. So what happened is we load our objects from this folder, and we load at apply format, so it has a standard that it follows, sorry. And to make sure that we are able to make our own loader, he changed the format a little bit. So he places the triangle indexes before, put the number of triangles here. Let me show you to compare here. So the format is very different. The vertices are at the end. So we have to make our own loader to load this sort of modifier apply file. So for this, what I did was this function, load finipply, and here I just use simple if string to make the load as he asked. It's not fancy at all, it's just doing the job. Okay, there's no need to describe this. And if we actually run this scene, so now but all those models are from his modified apply version. Okay. They are being loaded here with display underline X. Very simple. And for the last question, he wanted us to change the shader, so it was receiving one vec4 for material diffuse, and we were supposed to create this 4 uniforms with different values, R, G, B, and alpha, for like to be in the to substitute to be what this vec4 was doing, just to show that we can change parameters in the shader. Okay, so for this question I had created a different shader, I guess. Let me change for the 7th so I can see the shader that I create. Here, this question 7 shader, it's this practically the same shader, but we have here the 4 uniforms that are being passed from the C++ side. Here I create 4 GLint variables that will hold the location for those material diffuse variables. Okay. And here we're getting the uniform location in the shader for those variables. And finally, we're setting those variables here, put in a green color. And in the shader, what it's doing, it's setting the frag color, RGB and alpha, to the whichever value we put in the C++, passing through here. Okay. And what I did to show that this is working, I put the information in the wireframe stuff. So for the scene builder, I changed the Galactica to be wireframe, and as soon as it's wireframe, it will be using this shader, this tweaked shader. Okay, so let me show you working. You should be seeing a green Galactica in wireframe and the other objects all with the normal shader. That is. So here's the Galactica, all wireframed. And the other objects. Are being rendered with the normal shader, the regular one. Okay, this was my interpretation for this assignment. Was pretty cool to do, and I had fun doing this and learned a lot while implementing some stuff, especially the camera and the game objects for changing its position and stuff. Okay, so that's it. Thank you very much for watching.